Hello, my name is Tomas Krasinski. I welcome you to my modest DIY workshop. I would like to introduce you to the VACU vacuum clamping system. No workshop, whether DIY, professional or even industrial, can do without some kind of workpiece clamping. You will find a vise on every bench. You can clamp the workpiece in a carpenter's vise, use various mobile tables or trestles with sliding jaws, and, of course, a wide variety of different clamps. All of these clamping systems have one thing in common, one minor drawback. Namely, you clamp the material between the jaws, so there is always a risk of damaging the surface. The VACU vacuum clamping system takes a completely different approach. Air is sucked out from the space between the clamping device and the workpiece, creating a vacuum, and this force then holds the workpiece onto the clamping device. The heart of the VACU system is this central unit, which you connect to a standard workshop compressor that must supply at least 120 liters of air per minute. You can monitor the vacuum value on the pressure gauge, and the graph shown next to it shows at what air pressure from the compressor the vacuum is highest. It's at 8 bars, and at that moment, the vacuum pressure is about minus 0.8 bars. The VACU unit has a reinforced surface on top, and we can also securely attach it to the work surface using a clamp. The entire VACU system is very simple. Using push-in connectors, you can connect individual flanges to various clamping devices with tubes, whether it's a clamping plate, various milling templates, or clamping frames with suction cups. In this case, you can take advantage of high-quality components from Festo, which uni-max also offers. To prevent any dirt from being sucked into the space between the clamping device and the workpiece during the operation of VACU, we'll add a simple filter to the suction branch. For the VACU to function properly, the exhaust muffler must also be screwed on. And then you just need to connect the compressor and turn on the pump with the switch. Now, let's take a look at the different ways to use VACU. One of them is making a clamping fixture. And that's done using a wooden board that's at least 10 millimeters thick, sealing tape, and special threaded inserts. One of the best materials from which you can make a quality clamping board in home businesses is waterproof plywood. I chose the one that's 18 millimeters thick. And that's because it's stable enough to withstand the vacuum pressure, and it has one side made of smooth laminate, which is really durable. You can drill the hole for the threaded insert into the clamping plate using a drill. An 18 millimeters diameter isn't exactly a common size, and to avoid having to buy a special drill bit for it, you can also mill the hole instead. If you choose the right combination of hole saw, groove cutter, and guide ring, you can achieve basically any diameter you need. Insert the will insert into the hole on the other side of the clamping plate, and preferably tap it into some wooden material. We'll screw the flange with the pushing connector onto the nut, and for that, we'll need a 12 millimeters wrench. We'll flip the plate over and insert the filter insert, which is included in the package and is meant to prevent any dirt from the space between the clamping plate and the workpiece from getting into the VACU system. From the provided sealing tape, we'll cut strips as long as we want the clamping surface to be. The tape is self-adhesive on one side, it's foam, and the top side has a smooth layer. Clean the surface before gluing, so that the tapes stick well and we start gluing. We stick the strips together so that they overlap, and there are no gaps between them where air could escape under pressure. We'll place the workpiece on the clamping disc so that it covers the entire area defined by the tape. Thanks to the fact that the VACU unit continuously sucks air out, it can eliminate small leaks. For laminate or sheet metal, the clamping force is almost minus 0.8 bar. With plywood or solid wood that doesn't have a perfectly smooth and non-porous surface, the clamping force is a bit lower. However, it's still strong enough that you'll really have a hard time tearing the material away from the clamping plate. Yet it is still such that you will have really big problems. To tear the material away from the clamping plate, a pressure plate is much better than a round mat. You have access not only to the entire top surface, but also to all 4 edges all around. Another way to use the VACU is to create a clamping fixture, like a frame, using 1 or more similar suction cups. You can definitely take advantage of such a frame when handling smooth sheet materials. Besides reducing the risk of surface damage, the vacuum clamping system has other advantages. For example, it's not limited by the size of the jaw opening and so on. You can basically clamp any size workpiece. In the same way you can make a vacuum clamping plate, you can also create a milling template for mass production. On one side, you drive in the threaded insert, and on the other side, you stick on the sealing tape. To make a template, it is best to use either high-quality, high-density plywood or solid wood. Construction plywood or chipboard are too porous, and you would not achieve the necessary vacuum. To ensure the highest efficiency, the best tightness, and the creation of the highest pressure, it is a good idea to sand the workpiece smooth before milling and also clean the sealing tape so that it adheres to the surface as best as possible. The advantage of a routing template attached to the VACU is that you can route the workpiece all the way around in one go. And thirdly, although it sounds incredible, VACU can be used for gluing. For that, you'll need a polyethylene sleeve like this, a so-called vacuum distribution net, and a special nut with a washer. A flange for air exhaust needs to be installed into the bag. The nut is smooth on one side and has this kind of indentation on the other side. Then, 4 corners from the cut opening will be tucked in. For the pulling, we'll use a size 30 wrench on the nut and a size 12 on the flange. We'll take one end, fold it over a few times, and tape it again. We put the object to be ironed inside. Now, just for demonstration, we'll use corn, and we'll tape the other end to make it easier and quicker to access inside. We just fold it like this and secure it to the workbench using this kind of beam and 2 clamps. Now we can connect the suction guide and start suctioning. By fixing one end with a prism, we can easily unwrap the bag and replace the workpiece. In our case, we'll take out the corn and replace it with some real workpiece and give it a serious try. Purely hypothetically, we will need to glue 2 prisms together. For some reason, we don't want to smooth them with a chisel or a plane because we don't want to risk damaging their surface, and we need even pressure just in case. This method of pressing is perfect for things like foiling or veneering profiled kitchen doors. We can help ourselves by squeezing out the excess air, double-checking the alignment of the beams, and then we can turn on the VACU. The fact that the pressing with VACU has enough strength is evident from the glue that was squeezed out of the joint like this. And finally, one more great piece of news. Vacuum clamping systems were mostly available only for industrial companies or professional workshops. The VACU system is for everyone, so it's perfect for a DIY workshop. So if you decide to expand the clamping options in your workshop with a vacuum system, you definitely won't make a mistake with VACU. I'll say goodbye under the motto Happy Clamping, and I look forward to seeing you in the next video.